Okay, so yesterday we found this fun little relationship in the polynomials between Pascal's triangle and these powers of this polynomial 1 plus x.
Yeah.
Now we've got this, we think we've got this triangle, counting our cubes.
Yeah.
And we're going to try to see if there's an analogy to here.
Mm-hmm.
So the 1 all by itself would probably just be some polynomial to the 0 power.
Yeah.
Because
Just
why?
because anything to the 0 is 1. Yeah.
Anything to the 0 is 1. So let's see if we can try to understand what these 3 1s might represent. Now what did the 2 1s represent over here?
That represented that was the first row that represented 2 to the first power.
Right, when you summed it up it was 2
Yeah.
to the first. And what polynomial was that?
That was x plus 1 to the 1.
Okay. I'll write it as 1 plus x
Okay.
to the first power. That was the first row. And the 1 was there.
Yeah.
And then this x also had a 1 there.
Yeah.
Now we have 3 1s though.
What can we do with 3 1s?
How would you think would be a natural way to extend this?
Well, you could go 1 plus 1 plus x. Or maybe have a second variable.
Maybe we could have a second
1
variable.
plus x plus y to the 1 maybe?
1 plus x plus y to the 1, and then the x's and y's would mix. But we didn't seem to have 2 variables over here. Maybe one thing is we could look and see what happened here when we had 3 numbers. And what did happen here when we had 3 numbers?
Well, it was 1 plus x squared.
It was 1 plus x squared, which is what?
Which is 1 plus 2x plus x squared.
So this 1 here represented a 1. This 2 was there.
Oh.
And the third number related to the third variable.
Yeah.
Not really, but it's the same variable, it's just a higher power.
Well, maybe.
So if that analogy holds, what would you expect 1, 1, 1 to represent as a polynomial?
Well, 1 plus x squared.
1 plus x squared.
Well, if you cut out the even, if you cut out the rows with even numbered, if you have numbers and the number of numbers is an even number, if you cut out those rows, then you get something sort of looking like that triangle.
Yeah, that's exactly right. Good job. Because we had 2 blocks to make this row, right?
Yeah.
And this is a row here where there was only 1 block.
Yeah.
So here it was this row that had 2 blocks from yesterday. And this row had 4 blocks, just like that row. Now the numbers aren't quite the same. This went 1, 2, 1. Our row went 1, 1, 1. But it's a very good observation. And that has to do with the number of blocks.
Yeah.
Okay. So let's just see if this row here did represent 1 plus x squared. Let's say that was our new starting polynomial. 1 plus x squared all to the first power. What would you expect this to be? The
Well,
second row.
Well, we'd have the 1 here,
and that would be.
but then we'd have something we'd have a lot of stuff in the middle.
Yeah. How did we go from this row to this row, or this row to this
We
row?
raised the power.
Okay. So what would you expect this row to equal?
1 plus x squared squared.
Ooh. Ooh.
Ooh.
Now we can actually do that multiplication, right? Because that just means 1 plus x squared times 1 plus x squared. And how do you do that?
Well, you just have to multiply everything through.
Okay, so 1 times 1, 1 times x squared. What does that
Yeah.
give us?
That's gonna give us just this 1
1
plus x squared.
Plus x squared. What about multiplying the x through?
If x plus x squared plus x cubed.
What about x squared?
We have x squared plus x cubed plus x to the 4th.
I know we haven't talked about this so much,
No.
but that's okay. Okay.
Yeah.
Can you see why 1 times 1 is 1, and
Yeah.
1 times x is x, and
Yeah.
1 times x squared is x squared?
Yeah.
What do I get when I add this up? Actually, you can do this, even though you've never seen this before. What do I get when I add all this together? What adds with the 1?
Well, nothing.
1. What do I get when I do x plus x?
It's 2x.
What do I get when I get x squared plus x squared plus x squared?
It's 3x squared.
Is this starting to look promising?
Yeah, 1, 2, 3.
What do I get here?
It's 2x to the third power.
And what do I get here?
X to the fourth power.
That worked.
Look at that. I got 1, 2, 3, 2, 1. Just like I got there. 1, 2, 3, 2, 1.
Whoa, cool.
Just from this polynomial.
Yeah.
So wait a minute. So this polynomial somehow knows about counting groups of 2 blocks.
Wow.
What?
Polynomials aren't alive.
But you're right. Polynomials aren't alive. And remember how hard we worked to create this next row?
Yeah.
But we could just cube this polynomial, and we should probably get that.
Whoa.
Now that's a little hard to do right now, so
Yeah.
let's switch over to Wolfram Alpha and see what happens.
All right.
Yeah.
Okay?
Let's do that.
Yeah, let's do that. Oh, actually, wait. Before we do that, now you can also see from here why it took the 3 rows above it to get the next one. So like
Yeah.
this 2 plus 3 plus 2 gave us a 7. It's because when we do this multiplication, we shift everything over.
Yeah.
Shift it over none, 1, and then 2. So those 3 above add to give the number below. Okay, that comes from this polynomial. Okay, now we'll go over to Wolfram.
All right.
Yeah.